Hello everyone and welcome back to ASP.NET Core 1.0. My name is Steve Bishop, and in this video we're going to be talking about configuring our context. Now I'm not going to be actually doing any coding in this video. I'm just going to be going over the scaffolded context that was done by the Entity Framework tooling for our AdventureWorks database context. But understand that since there's been this merger of the code first and the database first methods of Entity Framework, what we're going to be looking at in our AdventureWorks context is code that we could use in our Contoso context. So more specifically, we're going to be taking a look at the OnModelCreating method, which is a method that we override in our context. There is an OnModelCreating method that comes by default with the DB context, but we'll talk about that a little bit more in this video. Just understand that we're overriding that default method. Now, the OnModelCreating method allows us to specify the database schema in code. So we can actually use the C# language to define some of the schema details that we want passed into the database. This allows us also to set navigation properties. And navigation properties are essentially properties that are objects that contain related data. Okay, so sometimes, especially in databases, we have some tables that relate to data in other tables. So we call this a foreign key and primary key relationship, or a one-to-many or many-to-many or a one-to-one relationship, where some data in one table relates to data in other tables. Now we get to that information in the C# language using these navigation properties, and we'll talk about them much more in this video. Something else that we can do then is define our primary keys, because obviously if we're going to have these navigation properties that define the relationships between the different tables, we're going to need to be able to define our primary keys. And we're also going to be able to define field constraints, things like the size of a field or a range. And these are just like the data annotations that we did in an earlier video where we added the attributes to the properties of our model classes, but we can actually define these same type of constraints on our properties using the OnModelCreating method. So let's go ahead and hop into our Visual Studio window and take a look at our AdventureWorks database context. So looking at our AdventureWorks context class, we can see that there is an OnModelCreating method. And the OnModelCreating method is overriding the default method that comes with the DB context class. And if you look at the DB context class, and you can't really see here because we're just looking at the metadata, but the DB context class, if you look at it in ILSpy, you'll find that OnModelCreating is really nothing more than a placeholder. There is no code at all whatsoever behind this OnModelCreating method. It's just there. And what happens is that Entity Framework will call the OnModelCreating method when it goes out and defines your database. Now it also helps with defining how the different entities are related to one another, and we'll get into that a little bit later. But for right now, just understand that the OnModelCreating method is going to be called in Entity Framework, and this gives us an opportunity to define the different types of constraints that are on our objects in our database, as well as some naming things, saying whether or not it's required, field sizes, that sort of thing. So if we look here in our OnModelCreating method, we're passing in a model builder class object, and that model builder parameter, then we're calling an entity method on that model builder. In the entity method, we're passing in a class type of database log. And then we're using a lambda expression to perform several different functions on that database log class. Now, for those of you who are unfamiliar with lambda expressions, don't worry, you're not going to need to know everything about lambda expressions and how they work, but I would urge you to go and do some research on what lambda expressions are, because they are an integral part of the C# language now. In the meantime, I'm just going to give you kind of an idea of what's going on here. Now, this isn't an exact concept of what lambda expressions do, but you can kind of think of what's going on here as like a for each loop. You can think of each database log item that is found in the database. We're going to perform, or we're going to call that item an entity. So just like with a for each loop, every iteration on a collection, you need to give that object some sort of name. So each time that you go through, you're giving each instance some sort of name so you can perform some function on that instance. And in this case, that's essentially what we're doing here. We're calling each database log object, we're giving it a temporary variable called entity. And then we're saying on that entity object, we're going to perform the following statements. Okay, so that's really a good way of thinking about it, is kind of like a for each loop. Now, typically, Lambda expressions are not always going to have these curly braces with multiple items to be run on them. Oftentimes, Lambda expressions have only one thing to perform on them. And when that's the case, you don't see the curly braces. So understand that essentially with curly braces, it's meaning for each one of these entity objects, I'm going to run all of these statements on it. And if you didn't need to run multiple statements and you only needed to run one, then you don't need the curly braces and you can just run that one method on it. So for example here, we see another Lambda expression in here where we're not using curly braces. We're just saying E goes into E database log ID. So now I hope that's not too confusing to you. I hope you guys can see how this, just at least get a general idea of how this is working with Lambda expressions. But again, I would really urge you to go out and understand how Lambda expressions work with delegates and func of t and action of t, that sort of thing. So we're saying then on each database log class object, we're defining a property, or look for a property called database log ID. So we're looking on the database log class for a property called database log ID. So let's go ahead and do that. Let's open up the class database log, and we can see the property database log ID. Now what we're going to do to that database log ID property is we're going to use the extension method has column name, and we're going to specify the name of the column, or the name of this property is database log ID. Now that may at first seem like a distinction without a difference, but if you look carefully, the name of the property has a lowercase d at the end, whereas the column name has a capital D at the end. Now let's go over here to the SQL Server Object Explorer, and let's, I'm just going to go ahead and pin this so we can take a look here at both screens. And we're going to expand this out and look at the database log table. And here we have the columns, and we can see that the database log ID field has a capital D. So database log ID, the column name of what goes into the database has been specified here. And we can see that it uses the capital I, capital D. So we're able to use these extension methods inside of this model builder entity method to define some of the characteristics of the various properties or the various columns in our database. We can also see down here that on the property called database user, we're saying it is required. Okay, so we're calling this is required method on that database user property. So database user right there is required causes it in the database to have the not null constraint. So in order for you to add a record then to this database log table, you must have some sort of value for database user. And the same thing goes for the event property. So we can see the event column here also has not null. If we look at the next property, the object property, we can see it has a column type of sysname. So if we look at the object, we can see that the sysname is the data type here, sysname nvarchar 128. So by saying it has a column type of sysname, that has declared it of a type sysname of nvarchar 128. And the same thing here for these other two properties, the post time and the schema. And then once again here for the tsql property, All right, the T-SQL property on our database log. Notice that it is lowercase SQL, but here in our context, we're defining that the column name is capital TSQL. And so here over in our database, we have capital TSQL. And of course, it is required, so we have not null. Then we can look at the XML event property, and the XML event property is of a type of string, but you can see the naming of it is XML with a capital X, capital E, but here on the column type, it's XML, so it started out as a string, right? It's a type of string, but to be more specific, we've said not just that, the column type is XML, so here we can see that the XML event is actually of a data type of XML. Now notice on the database log class, there is no data annotation. There's no attributes anywhere on any of these properties. So unlike what we had over here with our contact class where we defined it's required for the ID field, there's a min length, a max length, and then a min length and max length here, and that the data type is of type phone. So we defined it's a string, but we said it's also a phone, right? Well, that's similar to what we're doing here, where we're saying it's a data type of date time, for example, here. So the post time is a date time. Okay, so we're being very specific about the data type that's going into the database. And if we go down here to the dim account, we'll see some similar things here. For example, the has length on the property account type, or has max length here for the account description, right? So now if we look at the database, we're going to go to that table, the dim account table. Dim account table. Let's look at the column account description, and we can see that account description is nvarchar type 50. So that allows for the size of the account description to be 50 characters long. And just like we're having here, we're defining that as has max length right there on the account description property. So it's essentially doing the same thing, right? This has max length method that we're calling here on the account description property is doing identically the same thing as what we did here when we defined on first name that the max length was 50. These two things are doing exactly the same thing. Now, something you may have noticed as I've been going through this is that here, up at the top here where we defined the database log, we have in our database, the table in our database, we have a primary key called database log ID, and it's set to the primary key. Well, you may be wondering, how is that being set as the primary key? Where is this being defined at? And if you looked through the code on the AdventureWorks context, you would find that there's nothing that defines this property as the primary key. How did that happen? How did this primary key get set despite us not actually saying it's the primary key? Well, that's because Entity Framework looks at the naming convention of your properties, and anywhere that it sees ID, it automatically assumes that it's a primary key of that entity. So here we're saying database log ID, we've named it ID, and Entity Framework automatically assumes, okay, you've named it ID, so therefore it must be the primary key. But if we go down here to the dim account, table, we'll see that the account key is the name of the property, and it's the primary key. But since it's not named with ID anywhere at the end of it, we have to define it as the primary key. And so we call this has key method on it. So we're on the entity, we're saying it has the key, and then the property that is the key of this entity is the account key property. And then we're calling, we're going one step further here, and we're saying that the name of this constraint is pk dim account. So if you look down here at the keys, you'll see pk dim account. So you can give it a specific name of that constraint. So for those of you who are real big gurus on making sure that you've got some sort of naming convention to your constraints. Well, there you go. You can actually go ahead and name it. There is a default that it'll say, and I believe if it's primary key, it just does PK underscore and then the name of the table. So that's what we've got here, is it's just kind of set to the default. So this is really kind of unnecessary, but since we reverse engineered this database, Entity Framework went ahead and it noticed that we had a name for it, so it went ahead and said that it was defined here in our context. Now, I'm going to get into something a little tricky conceptually here, so please bear with me. There is, in database circles, something known as one-to-many, many-to-many, and one-to-one relationships. And that is, sometimes you have tables where information in one table references information in another table. That way you don't have to have all of the information in one table. You can kind of split it up and do something called normalization. Now, because of this relationship between the different tables, you also need to define those relationships in your classes. But not only do you need to define them in your classes, you need to define them in your context. So here we have, on our dim account class, there is a situation in this database where an account can have a parent account. So one dim account record can refer back to another dim account record, and that record that it's referring to is a parent account. Now, conversely, one dim account or a parent account might have several children account, right? Because one account could have multiple accounts that spawned from it. So to define this tricky scenario, there's a couple of things that have been set up. One, in the dim account class, there's some properties that have been created. And number two, the relationship between the different dim account records has been set here down at the bottom here as part of a constraint. So let's just kind of go through this here. Let's first take a look at the dim account class. I'm going to close those classes there. So let's take a look at the dim account class. And on our dim account class, there is a public virtual dim account called parent account key navigation. So this property called parent account key navigation is of a type dim account, and that is the same dim account class type that we actually have here. So it's kind of self-referential, right? We have a property of the same type that is the class that we're looking at. And that can seem a little counterintuitive, but if you think back to the description that I gave you of a parent and child, where a parent account might have several children account, this kind of makes sense. The reverse flow of it is that a child account needs to know who its parent account is. And so we've defined that parent account as a property, and that data type is of a dim account. Notice also that we're using the virtual keyword. And virtual means something in Entity Framework. It means that this is a navigation property, okay? And a navigation property is a fun thing. It's a really useful tool in Entity Framework. It means I can go from one entity and navigate to using this property, this parent account key navigation property, to go look at that object. So I can first start out with the child account and then use dot notation with the parent account key navigation property and to go look at the parent account. So go get the information of the parent account of this child account that I'm looking at. Now we'll get into some of that when we start to actually extract the data and kind of do some of our queries and our Lambda expressions to go get the data and then display it to our views. But for right now, just understand that this parent account key navigation property here is of a type dim account, which is referring back to a parent account. Now conversely, if this record that we were looking at was the parent account, then that parent account would need a collection of children accounts, right? So child accounts. So it's a collection of dim accounts that represents all of the children accounts that spawned from the parent account. And the property name that's been given to that collection of children accounts is inverse parent account key navigation. Now, I didn't come up with that naming convention. I don't know why that's what they called it in the AdventureWorks database. It seems a little silly to me. It should probably just be child accounts. But that's what they've decided to name this property that is a collection of all of the child accounts. Now, since there is a direct, essentially a one-to-many relationship, and this child account has one parent account, that one parent account, we need to store the primary key of that parent account. Okay, so looking at it from the child account, we're looking at it, just assume we're looking at a child record. That child record needs some sort of value that refers back to the parent account's ID. Okay, so the primary key of that parent account. And we can see over here in our database, on our dim account table, we have this parent account key. And we can see right here, parent account key. So there's a relationship between this navigation property and this int parent account key. That is, this dim account record, we can look to the parent account key to find what is that parent record that this property is looking for. Okay, so just understand that relationship. We've got a dim account that is the parent account, and its key, its foreign key, is stored right here in the parent account key property. Now let's go back to the context. And here we have the entity, and we're looking at an account. Okay, so an account object can have one parent account key navigation property. So it has one parent, okay, has one parent account. Now that one parent account can have many child accounts. Okay, so look carefully at this. The entity has one parent account key navigation, so it has one of these, but that parent account can have many inverse parent account key navigations, right? So this inverse parent account key navigation, it can have many, and of course that makes sense since it's a collection. A collection is made up of many of something. So that parent account has many child accounts. Now we're defining the foreign key by using the hasForeignKey method. And the hasForeignKey method, we're passing in a lambda expression to define that property, right? The property that defines the foreign key of the parent account is parent account key. So that refers back up here to the parent account key property. Then finally, we're having this hasConstraintName method, and we're naming our constraint fk dim account. And this kind of makes sense because it is a self-referential constraint, right? One account is referring to another account. It doesn't refer to some other object in some other table. So we have this hasConstraintName, and you can see right here where the keys are being defined, it's fk dim account. So I hope you guys understand how all of that works, but there is the definition of our relationship between two accounts. And we can look at other instances. That's kind of a more complicated one because it's a self-referential, right? One account's referring to another account, which can be a little confusing. So we can look for another instance of a foreign key and primary key relationship just by looking at the customer table. So I'm going to go ahead and look at the customer table. And on the customer table, we have a geography key as a foreign key. And then, of course, we've defined our customer key as the primary key. So here we have, once again, on the dim customer table, we're defining that it has a key called, and that property that is the key is customer key. So let me just close that and let's open up the customer. And we're saying that, again, the customer key property is the key of the dim customer class. So there's our customer key. And once again, it's not null because it's an int and doesn't have the null symbol next to it. So our customer key has to have some sort of value, and we're defining it as the key using the hasKey method, and then hasName, and we're defining once again the constraint down here in our keys that the pk dim customer underscore customer key is the primary key. There it is right there. Okay, so now we got that all sorted out. Let's take a look. Look at that. We can even define indexes for those SQL geeks out there who like indexes. There you go. We can have an alternate key as an index. If we scroll down here to our has one and has many, so this is the definition of the relationship between the objects, we'll see that it has a property called geography key navigation. So the geography key navigation, if we scroll down here, geography key navigation property. And that geography key navigation property is of a type dim geography. So there is a relationship here that a dim customer class has a property that points to a geography, right? A dim geography or a geographical location. And it is a navigation property, and we can tell that not just because of the name, but because we have a virtual keyword here. So if we go back to our context, we can see that we're saying it has one geography key navigation property. And that's right, there's only one of them, right? It's not a collection, it's just a single dim geography. But that dim geography class has many dim customers. Okay, so if we go look at the dim geography class, we're going to see down here that it has dim customer collection, right? It has a collection of customers, and that property is dim customer. So that's where we see with many dim customers. And then we're saying it has a foreign key. So the has foreign key is, what is the foreign key of that geography key navigation property? Well, that foreign key property is called geography key. So if we look at the dim customer class, we can see, there we go. The geography key property is where we contain the foreign key value for that property of geography key navigation. Okay, so that is being defined there. And then, of course, once again, we're defining the constraint name as fk dim customer dim geography. And there it is right there, foreign key dim customer dim geography. So that is how all of that works. That is how we've gone over now some of the ways that you can add constraints to the different properties. So we can say that it's required. We can say it has certain lengths, and there's a whole slew of other extension methods we can call on this. I'll leave it up to you to go and explore what those are. But we can also say, or we can also define the relationships between our classes and our objects in our database. Okay, so there you go. I hope that that has all made a lot of sense to you. I know I didn't really do an example of this. I kind of just went through the actual context in AdventureWorks context, but as we build out our Contoso context, we're going to start to do some of these things in the OnModelCreating class, especially when we start getting into the big kahuna and the big reason why OnModelCreating is really even that important to me. And that is when you have a complex key, or when you have a composite key where multiple fields make up that primary key. So anyway, I hope that this has been a good lesson for you guys. If you enjoyed it, please don't forget to like, favorite, and subscribe. And of course, if you have any questions or comments, please feel free to drop them in the comments section below this video. And as always, I will look forward to seeing you guys in the next video.